Alright guys, these are just some quick notes on 1.5 here for us so that we can get a little bit of a head start. So, 1.5 is about solving multi-step equations. One thing that you need to always note when you're solving multi-step equations is that we need to think PEMDAS. But when we solve, we think of it backwards. So we need to do the adding and subtracting first, multiplying and dividing next, and then we get into the exponents, and then finally the parentheses. So, solve the following question. When we're solving, we have to isolate the variable. So in this case, 20 is being subtracted from x. So in order to isolate it, we would have to add the 20 to the other side, right? The opposite operation of subtraction. So that would give us x is equal to 1. And then we're done. Okay, so that's not a multi-step equation, that's just a one-step equation. And that's okay, we're just warming up here. So the next one, 13, is being added to k because it's a positive 13. So in order to get that off of there, we subtract the 13 from both sides. And now we have k is equal to negative 15. Okay, the next one is our first multi-step equation. So, multi-step just means that it's more than one. Well, this is a negative 10, so in order to get a negative 10 off, we have to add 10 to both sides. Remember, always thinking opposite PEMDAS, so I'm doing my adding and subtracting first. When we do that, the 10s cancel on the left, and we have x over 3 is equal to negative 6 plus 10, gives us 4. To finish this problem, to undo division, we multiply, so we multiply both sides by 3. That's going to give us x is equal to 12. Next up, we have, again, another negative out front here. So in order to get that negative off, we're going to add 2 to both sides. When we do that, that leaves us with negative 7m is equal to 14. And then to undo multiplication, we divide. So we're going to divide both sides by negative 7, and that gives us m is equal to negative 2. Awesome. So, this next one, this one can get a little tricky because we have something in the top and something in the bottom of a division problem. Well, what you need to know is that whenever there's stuff in the bottom and the top of a division problem, we need to put those things in parentheses. So, if we think about this one, we have parentheses here, which is the very last thing we're allowed to do, is parentheses when we're solving. So in order to get those parentheses by themselves, we first need to undo the 8 that's being divided. So we have to multiply both sides by 8. Now we have a 10 plus k that's by itself is equal to negative 8. Then we just subtract the 10 from both sides, and we'll get k is equal to negative 18. All right, for f, okay? Again, f is just like the last one. We have a parentheses, so we can't do anything inside of the parentheses until we get whatever's on the outside of them off. So then what I'm going to do is I would divide this side by 7, and then I would divide this side by 7. What that does is that cancels the 7s. So then we have negative 70 divided by 7, which would give us negative 10, and then that's equal to negative 10 plus 10. Okay, now we would just add the 10 over to the other side. But what happens when we do that? We would get 0 is equal to n. Okay, so that's a couple multi-step equations for you. The last two down here, okay? For g, there's only really one way that I would do g, because this is really just a one-step problem here, guys, so we don't need both of these squares. The one step here, right, we have m divided by 18. Well, how do we get 18 off of there? Well, we just multiply the 18 to both sides. And then the biggest thing is, how do we do 18 times negative 1/6? Well, this is the same as saying 18 times 1, which that would give us negative 18 over 6, so that's equal to m, okay? And then 18 divided by 6, when we simplify, gives us negative 3. So then our final answer is just negative 3 is equal to m. Okay, this other one though, there are two ways to do this question, so let's talk about those two ways. There's kind of, in my opinion, there's a difficult way and there's an easy way. So we'll do this what I think is the difficult way first. So we have 5/3 plus 1/2 n is equal to 11 over 6. So the difficult way is to just leave these things all as fractions, okay, and solve them that way. So, in order to do that, what we would have to do is we'd have to get 6's on the bottom of all of these, because 6 is the biggest fraction here. So then in order to do that, what's going to have to happen is we're going to have to take this first term, multiply it by 2 over 2. Okay, the reason we're allowed to multiply by 2 over 2 is because 2 divided by 2 is just 1. So we're not changing that number at all. So that would give us 10 over 6 for the first term. The next term we have to multiply by 3 over 3. So that would give us plus 3 over 6n. And then that's equal to 11 over 6. Now that all of the denominators are the same, we can now just do some adding and subtracting. So we subtract off the 10/6 from both sides. We get 3/6n is equal to 1/6. Okay? And then to undo this last part right here, to get rid of a fraction being multiplied by something, we have to multiply by its reciprocal, so 6/3. So then you see the 6 would cancel with the 6, the 3 would cancel with the 3, and then we're just left with n. So we're going to multiply by 6/3 on the other side. And then look what happens here. 6 cancels with 6, and then what we get is n is equal to 1 over 3. Boom. Done. Okay? Now, what I think is the easier way to do this is, well, let's just cancel all of the fractions right at the beginning. So we have 5/3 plus 1/2 n is equal to 11/6. So did you see how 6 was the common denominator here in the last question? Okay, well, we can actually use that 6 to our advantage. 6 is called the least common denominator in this case. And the way to find the least common denominator is usually to multiply all of them together. But in this case, when we multiply 3 and 2, we get the number 6. So 6 is actually just our least common denominator. So if we take the least common denominator and then we multiply everything by it, so we're going to multiply everything by 6, then we would distribute 6 here, we would distribute 6 here, and we would distribute 6 here. Why is that helpful? Well, let's write it out. 6 times 5/3 plus 6 times 1/2 n equals 11 over 6 multiplied by 6. Well, on the right side, 6's cancel, we're left with 11. On this side right here, 6 times 1/2, right? So we would take 6, we would divide it by 2. That would give us 3n, okay, for 6 multiplied by 1/2. And then 6 multiplied by 5/3, 6 divided by 3, those things cancel and leave us with a 2. 2 times 5 gives us 10, so that would be 10 plus 3n is equal to 11. Now we can just solve this question, and it's all whole numbers, so we subtract 10 from both sides. We get 3n is equal to 1, we divide both sides by 3, and we get n is equal to 1/3. So, in my opinion, using the least common denominator to cancel out all of the fractions is a little bit easier than trying to just work with fractions the whole time. Okay? But really, guys, the preference is up to you. If you're comfortable with fractions, definitely do the fraction way. If you're not comfortable with fractions, then I would suggest using the least common denominator to cancel things out. Okay? This last one that I want you guys to try on your own is a little bit trickier, right? 6 is not the least common denominator in this case. For this one, we have to think about it a little bit. So we have 3, we have 2, and we have 9. We need to think of the smallest number that we can make with all 3 of those numbers. So what I'm thinking is it has to be an even number because we have 2 involved. So the lowest even number we can make with 9 is 9 times 2. That would give us 18. So the question becomes, can we make 18 out of 2, and can we make 18 out of 3? Well, we can make 18 out of 2 because 2 times 9 gives us 18. And we can make 18 out of 3, right? So 3 times 6 also gives us 18. So we can make 18 with 9, 18 with 2, and 18 with 3. So our least common denominator in this problem is going to be the number 18. Okay? So now that you know that, pick either way that we just did the last question to solve this one. Okay? So that's all for the 1.5 intro. We'll be working more with 1.5 next week. So please come with questions that you have from this video, guys. I hope you're having a great weekend, and I will see you soon.